Today, we're going to talk about something truly transformative, the science of how to hack your brain. Now, when we say hack, we're not talking about shortcuts. We're talking about deliberate strategies rooted in neuroscience that can fundamentally improve how your brain works, your focus, memory, mood, and even motivation. Let's begin with the foundation of it all, neuroplasticity. This is your brain's ability to rewire itself based on experience. Contrary to old beliefs, your brain is not static after childhood. Every time you learn something new, shift your focus, or even breathe a certain way, you are shaping your brain. The key to using this power is attention plus repetition plus rest. When you intensely focus on a task, repeat it deliberately, and then rest, especially with quality sleep, your brain rewires to make that skill or knowledge stick. But that leads to an important question. How do we control our focus in the first place? Here's the science. Your brain has a built-in spotlight, controlled by your prefrontal cortex and neuromodulators like dopamine and acetylcholine. You can enhance these through behavior. For instance, staring at a fixed point for 30-60 seconds actually increases neural activity in focus-related circuits. This is a simple way to prime your brain before deep work. Next, let's talk about motivation. Many think motivation is something you wait for. Neuroscience tells us the opposite. Motivation follows action, not the other way around. When you take a small step, even a few minutes into a task, your brain releases dopamine, which reinforces the behavior. This feedback loop is how habits are formed. Want to feel motivated more often? Move before you're ready. The biology will catch up. Neuroplasticity is your brain's superpower. Harness it daily. At its core, neuroplasticity is the brain's ability to change its structure and function based on experience. This means that your brain is not a fixed, unchanging organ. Instead, it is dynamic, adaptive, and responsive to what you do, what you think, and even what you feel. This concept has revolutionized neuroscience in the last few decades, proving that learning and mental growth are not limited to youth but available across the lifespan, if you know how to activate the system. Neuroplasticity operates through the strengthening and weakening of synaptic connections between neurons. Every time you engage in a new behavior or skill, like learning a language, playing an instrument, or solving a problem, certain neural pathways are activated. When this happens repeatedly and under focused attention, the connections between those neurons become stronger. The phrase "neurons that fire together wire together" is a simple but powerful way of describing this mechanism. On the flip side, when certain connections aren't used, the brain prunes them away, conserving energy and space for more relevant tasks. This is called synaptic pruning, and it ensures that your brain remains efficient and responsive to the environment. For neuroplasticity to occur in a meaningful way, three conditions must be met: focused attention, repetition, and rest. Focused attention is the ignition key of plasticity. When you bring deliberate focus to a task, especially something difficult or unfamiliar, you signal to your brain that this information or skill is important. This triggers the release of neuromodulators like acetylcholine and dopamine, which act as flags at synapses, marking them for strengthening. Acetylcholine increases the precision of neural signaling, helping your brain lock onto the relevant stimulus, while dopamine encodes the reward value of learning, making you more likely to repeat the action. Without these neurochemicals, even the most intense study session won't leave a lasting trace in your brain. Repetition is the second ingredient. Think of each repetition as a pass over a dirt path in the forest. At first, your footsteps barely make a mark, but over time, with enough passes, a clear trail forms. Similarly, the more frequently you activate a neural circuit, the more likely it is to become a permanent part of your neural architecture. This is why consistent, structured practice over time is far more effective than cramming. The brain favors spaced learning because it allows time for both reinforcement and consolidation. Practice that is interleaved with effort and slight struggle, the kind that demands correction and adaptation, activates deeper levels of learning and leads to more robust plasticity. The final and often overlooked component is rest, particularly sleep. Sleep is not passive, it is the most active time for neuroplasticity. During slow, wave, and REM sleep, your brain replays the activity patterns you engaged in during the day. It's as if the brain is rehearsing, stabilizing, and integrating what you've learned. This is the consolidation phase, and it's essential. If you don't sleep well after a learning experience, many of the neural changes triggered during practice simply won't solidify. In fact, studies show that performance on memory and motor tasks improves significantly after a good night's sleep, sometimes even more than after additional practice. So while waking behavior initiates neuroplasticity, sleep completes the process. It's also critical to understand that neuroplasticity is competitive. The brain is constantly evaluating which circuits to strengthen and which to let go. This means your daily habits shape your brain just as much as your deliberate efforts. If you spend hours scrolling or multitasking between apps, you're reinforcing circuits related to distraction. If you engage in regular reading, problem solving, or reflection, you're strengthening focus and comprehension pathways. What you pay attention to grows, what you ignore fades. Neuroplasticity doesn't care what you practice. It only cares that you do it consistently. Harnessing neuroplasticity isn't just about becoming smarter. It's about taking control of how your brain evolves in response to your choices. You can train it to be calmer under stress, faster in thought, more agile in solving problems, or more emotionally resilient. But to do that, you must approach brain training like physical training, understanding that progress is slow, deliberate, and entirely dependent on effort. The tools are available: focused practice, repetition, sleep, and behavioral alignment. Used wisely, these tools don't just change how you think, they change what your brain is, and that is the true power of neuroplasticity. Focus and motivation are trainable through deliberate behavior and biology. These aren't fixed traits you're born with or destined to lack. They are dynamic processes shaped by your actions, environment, and internal neurochemistry. The brain doesn't just passively receive information or inspiration. It responds to inputs in ways that can be guided, strengthened, and repeated. That means your capacity to concentrate deeply or sustain effort over time is not a matter of willpower alone. It's a function of how you regulate your nervous system, your hormones, and your habits. Focus begins with the brain's ability to filter out noise and lock onto one source of input. This is largely governed by the prefrontal cortex, a brain region responsible for executive functions like decision making, planning, and attention. When you begin a task and maintain your attention on it, certain neurochemicals, primarily acetylcholine and norepinephrine, flood key circuits, enhancing signal-to-noise ratio. Acetylcholine sharpens your perception, making the brain more responsive to what matters, while norepinephrine boosts alertness. But for this system to work optimally, your behavior must signal to your brain that focus is needed. Sitting down without distraction, creating intentional visual and auditory space, and even using simple rituals like a timer or deep breath at the start of a session all help trigger this chemical cascade. Sustained focus over time, what we often call deep work, is more than a mental choice. It's a biological process. Your brain naturally resists long periods of intense attention because it consumes energy. That's why practicing in intervals like 90-minute ultradian cycles or 25-minute Pomodoro bursts is effective. These methods align with your brain's natural rhythms. More importantly, repeated sessions of intense focus actually strengthen the neural circuits responsible for attention. Just like lifting weights builds muscle, returning to a mentally demanding task day after day builds cognitive endurance. The more you train focus, the more efficient those brain circuits become. Motivation is often misunderstood as something you either feel or don't feel. In reality, motivation is closely tied to the neurochemical dopamine, which plays a central role in goal-directed behavior. Dopamine is not just the molecule of reward, it's the molecule of pursuit. When you anticipate achieving something meaningful or challenging, your brain releases dopamine to energize action toward that goal. This means motivation can be generated by taking steps toward a meaningful target, even if you don't feel it at the start. Action leads to dopamine release, not the other way around. That's why the key to becoming more motivated is to begin. Even small wins, like opening the document, writing a few words, or completing the first rep, trigger a biochemical response that makes you want to continue. A powerful way to train motivation is to create what's called a dopamine feedback loop. This involves setting specific, achievable goals, breaking them into milestones, and mentally rewarding progress as you make it. When you acknowledge that a small task is part of a larger mission, your brain attaches significance to it and releases more dopamine when it's complete. Over time, your system learns that effort equals reward, and motivation becomes a learned response to forward progress. You can literally train your brain to associate challenge with pleasure by reinforcing the process, not just the outcome. Biology also plays a role in both enhancing and sabotaging focus and motivation. Poor sleep, irregular light exposure, erratic eating habits, and lack of movement all disrupt the delicate balance of neurochemicals that regulate your mental state. For example, insufficient sleep reduces dopamine receptor sensitivity, which makes effort feel harder and rewards less satisfying. Inconsistent light exposure throws off your circadian rhythm, leading to low alertness during the day and racing thoughts at night. On the other hand, early morning sunlight, moderate caffeine, hydration, and regular movement act as performance enhancers, not through magic, but through predictable effects on your hormones and neurotransmitters. Another overlooked tool in focus and motivation training is deliberate discomfort. The brain grows most when it's challenged just beyond its current capacity. When you deliberately do something difficult, whether it's a cold shower, a hard workout, or sitting in silence with a complex problem, you teach your brain to tolerate discomfort without retreating. This strengthens the circuits for discipline and builds resilience. In fact, studies show that people who expose themselves regularly to controlled stressors have higher baseline dopamine levels, better stress tolerance, and greater cognitive performance under pressure. Ultimately, focus and motivation are skills built through repetition, biological alignment, and strategic self-regulation. Every time you train your mind to return to a task or push forward in spite of resistance, you're not just completing a task, you're rewiring your brain to become more capable, more directed, and more intrinsically motivated. This is the power of aligning your behavior with your biology. It is not just about working harder, it's about working smarter by understanding how your brain functions and using that knowledge to your advantage. The role of rest and recovery in optimizing brain function cannot be overstated. While it is tempting to think of productivity and mental sharpness as products of nonstop activity and relentless effort, the truth is that the brain requires periods of downtime to function at its best. Rest is not simply the absence of work. It is an active, dynamic process that supports memory consolidation, emotional regulation, creativity, and cognitive resilience. Without sufficient rest, the neural machinery that underpins learning and decision-making begins to falter, leading to reduced focus, impaired memory, and even heightened stress responses. Sleep is the cornerstone of this restorative process. During sleep, the brain undergoes multiple stages, each with distinct but complementary functions for mental optimization. Slow wave sleep, also known as deep sleep, is critical for consolidating declarative memories, the kind of information you consciously recall like facts or events. During this stage, the brain replays the patterns of activity it experienced during waking hours, essentially rehearsing and embedding new knowledge into long-term storage. This replay also prunes away extraneous synaptic connections formed during the day, streamlining neural networks for efficiency. Without enough slow wave sleep, learning new information becomes far more difficult and recall suffers. REM sleep, or rapid eye movement sleep, serves a different but equally vital role. This is the phase where dreaming occurs and is associated with the processing of emotional memories and the integration of new knowledge with existing frameworks. REM sleep helps the brain make creative connections between seemingly unrelated concepts, which is why many insights or problem-solving breakthroughs happen after a good night's rest. It also contributes to emotional resilience by regulating the activity of the amygdala, the brain's fear and stress center. Lack of REM sleep leaves the brain more reactive to stress and less able to manage emotional challenges, impairing overall cognitive function. Rest is not limited to nighttime sleep. Short breaks throughout the day are essential for maintaining cognitive performance, particularly during periods of intense focus. The brain has a natural rhythm of about 90 to 120 minutes called the ultradian rhythm, during which focus and energy rise and fall. Pushing beyond this natural peak without rest leads to mental fatigue, decreased productivity, and increased errors. Taking even brief breaks, standing, stretching, or shifting attention to a different activity, allows the brain to reset. This not only prevents burnout, but also enhances creativity by encouraging shifts in perspective and allowing subconscious processes to work in the background. Mindfulness and meditation practices are increasingly recognized as powerful forms of rest that actively restore brain function. These practices promote a state of relaxed awareness, decreasing activity in the default mode network, which is associated with mind, wandering, and self-referential thought. By calming this network, mindfulness reduces mental clutter and stress, improving the brain's ability to focus when needed. Regular meditation has been shown to increase the density of gray matter in areas responsible for attention, emotional regulation, and decision-making. These changes translate to improved mental clarity, emotional balance, and resilience under pressure. Physical recovery is also tightly linked to brain health. Exercise enhances neurogenesis, the growth of new neurons, particularly in the hippocampus, the region involved in learning and memory. After physical activity, the brain increases production of brain-derived neurotrophic factor BDNF, a protein that supports neuron survival, growth, and synaptic plasticity. However, this benefit is maximized only when the body is allowed sufficient recovery time. Overtraining or chronic physical stress without adequate rest can increase cortisol levels, the stress hormone, which impairs cognitive function and suppresses neuroplasticity. Balancing exercise with rest ensures the brain receives the optimal hormonal environment for growth and repair. Nutrition and hydration also play a vital role in rest and recovery. The brain consumes about 20% of the body's energy, primarily in the form of glucose. Without steady, balanced nutrition, brain cells cannot function optimally, and recovery processes slow down. Adequate intake of essential nutrients like omega-3 fatty acids, antioxidants, and vitamins supports the repair of cellular damage and protects against inflammation, which can disrupt cognitive function. Staying hydrated ensures efficient blood flow and nutrient delivery to the brain, which supports all restorative processes. Technology habits significantly influence rest quality and, by extension, brain function. Exposure to artificial light, especially blue light from screens, suppresses melatonin production, a hormone crucial for initiating sleep. Using devices late at night delays the onset of sleep and reduces overall sleep quality. Furthermore, engaging with stimulating content before bed increases cognitive arousal, making it harder to fall asleep. Establishing tech-free wind-down routines and dimming lights in the evening signal the brain that it's time to prepare for rest. These simple behavioral adjustments enhance the brain's ability to enter restorative sleep cycles. The brain's capacity to function at its peak depends on how well it is supported by rest and recovery. This means that periods of mental effort must be balanced with intentional downtime. Without rest, the brain's ability to learn, adapt, and regulate emotions deteriorates. By prioritizing quality sleep, incorporating regular breaks, engaging in mindfulness, balancing physical activity with recovery, maintaining good nutrition, and managing technology use, you provide your brain with the essential resources it needs. These restorative practices aren't signs of weakness or laziness. They are fundamental biological necessities that empower you to operate at your highest cognitive level. In understanding how to truly hack your brain, it becomes clear that optimizing mental performance is not about quick fixes or sheer willpower alone. It's about aligning your behaviors with the brain's natural biology, training your focus and motivation through deliberate practice, nurturing your nervous system with proper rest and recovery, and shaping your environment to support sustained cognitive health. By embracing this holistic approach, you empower yourself to unlock deeper concentration, resilient motivation, and lasting mental clarity. The brain is a dynamic organ capable of profound growth and change, and with intentional habits grounded in science, you hold the key to harnessing its fullest potential. This is how you truly hack your brain, by working with it, not against it.